Okay, so in the lecture 1 of chapter 2, we have learned some concepts regarding the angles, right? So today we'll have a look at the parallel lines. Okay, so today we're going to have a look at the definition of parallel lines and angles between a transversal and two parallel lines, and some property theorems regarding parallel lines and judgment theorems. Okay, so let's have a look at them one by one. First of all, let's have a look at the definition of parallel lines. So in geometry, if two lines are coplanar and do not intersect at any point, we say that they are parallel. So the definition is quite intuitive, right? For example, as shown in this figure, if line AB and CD are parallel, we can write line AB parallel with line CD. We use this symbol to indicate these two lines are parallel. Understand? And if you want to show the parallel lines on the graph, usually you can use a small arrow to indicate all the lines that are parallel. For example, in this figure, line K, J, L are parallel. Then we can use 3 little arrows to indicate these 3 lines are actually parallel. And then line M and line N are parallel, are indicated by 2 small arrows. Okay, so these 2 small arrows indicate that line M and line N are parallel to each other, but not necessarily parallel to line K, J, and L. Any questions?
No.
Okay. All right, then if 2 lines are parallel, there are some angles between a transversal and 2 parallel lines. So let's have a look at this figure here. There are 3 lines, right? M, N, and L. Suppose line M is parallel to line N, and L cuts across parallel lines, M and N. We call line L is a transversal. Okay, remember this term, transversal line. And of course, there are 8 angles, right? Angle A and angle E are called corresponding angles. And angle D and F, let's use a different color here. D is here, F is here, are called alternate interior angles. And angle A and G are called alternate exterior angles. And angle C and F are same side interior angles. B and G are called same side exterior angles. So these are just names. So as we dig deeper, I think you will get familiar with these names of angles. Okay, so I think currently you can just write their names onto your notebook, and we'll refer to the names of the angles in our following discussion. Okay, I'll give you some time to write down the names of these angles. Okay, let me know if you finish, okay?
Okay.
All right, if you finish, let's do a little practice here. Okay, suppose we have 3 lines. M is parallel to N and L is a transversal. Then we have A, B, C, D, F, G, H, 8 angles. So let's connect each pair of angles to its correct name. I'll give you 1 minute to think about this question, okay? And I think you can just write on the screen. Okay, write your result on the screen. For example, A and E is called corresponding angles, right? You can finish the rest of the names. Okay, thank you very much. Okay, you have given a correct result. I should mention that these three angles, okay, these three types of angles, corresponding angles, alternate interior angles, and same-side interior angles are most commonly used in our further discussion, okay? All right, so next, let's have a look at what properties they have if two lines are parallel. So there are 4 property theorems. Property theorem 1 states that if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. So for example, if we have line M parallel to line N, and line M is parallel to line N, and line L is a transversal. Then in the 8 angles here, the corresponding angles are congruent. Therefore, A equals B, C equals D, E equals F, G equals H, because each pair is a pair of corresponding angles, right? Any questions?
No.
Okay, so why is it called property theorem? Because people have proved this statement is actually true. We'll see how we can prove this later, okay? So before we do that, let's just learn the 4 property theorems. Okay, property theorem 2. Oh, do you need to take any notes here?
Okay.
Okay, actually, if you you can take a brief notes, for example, 2, you can write parallel lines indicates congruent corresponding angles, right? If you write quickly, you can write it like this. Parallel lines indicates congruent corresponding angles. Okay, next, property theorem 2, which states that if 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. For example, if line M is parallel to line N here, and L is a transversal, apparently angle A and angle B are called alternate interior angles, right? Also, angle C and D are also called alternate interior angles, right? Therefore, if the statement states that if M is parallel to N, L is a transversal, then A equals B and C equals D. That means parallel lines indicates congruent, alternate interior angles. Okay. Let me know if you finish. Okay.
Okay.
All right. Next one is property theorem 3, which states that if two parallel lines are cut by transversal, then same side interior angles are supplementary. For example, in this figure, we have line M parallel to line N, and L is a transversal, right? And A and D are the same side interior angles. Therefore, A plus D equals 180 degrees, right? Because they are supplementary. And angle C and B are also same side interior angles. Therefore, C plus B is also 180 degrees. Okay. Again, let me know if you finish, okay?
Okay.
All right. And the other property theorem states that if two lines M and N are parallel, then every point on line M is located at exactly the same distance from line N. Okay, for example, in this figure, we have two lines M parallel to N. If M is parallel to N and we choose a arbitrary point on line M, for example, A here, and find the distance between M and N, that means AB is perpendicular to line N, right? And the distance here, AB, is a constant everywhere on line M. Understand? For example, you choose another point, find the distance between this point and line N. Let's call this C and D. This length is also a constant, which is equal to AB. And this distance actually is a constant everywhere, right? This is a property theorem 4. Okay, let me know if you finish.
Okay.
Okay. Then, as I said, the reason we call them property theorem because people have proved each of the property theorems is correct. Therefore, let me show you how we can prove each of the property theorem correct. So first of all, let's try to prove property theorem 1. Okay, if you want to prove the property theorem 1, the question is actually like this, right? As shown in this figure, given that line M parallel to line N and L is the transversal, prove A equals B, right? This is our question. Okay, how we can prove this? Because so far we have not learned any theorems yet, right? Before we learn property theorem 1, we only learned Euclid's 5 axioms, right? Remember what is called an axiom or postulate? These are widely accepted facts, right? We can only start from these 5 axioms or postulates. We haven't learned any theorems or we haven't proved any theorems yet, right? So these are the only axioms we can use to prove the property Serum One. Okay, so how we can prove this? The key is to use Euclid's fifth axiom, which is also called Euclid's fifth postulate. Okay, we can do it like this. Okay. Our goal is to prove A equals D, right? A equals B, right? Well, we can do it this way. We can assume A is not equal to B. Okay, let's assume A is not equal to B. That means A is either greater than B or less than B, right? It is okay to assume A is greater than B. Otherwise, we can follow the same logic to prove this, right? Okay, so let's say it is okay to assume A is greater than B. Okay, so follow this logic. If A is greater than B, what will happen? Then we have, so let's call this angle here angle C. If A is greater than B, we have, because A plus C is 180 degrees, right? Because this is a straight angle. So A plus C is 180 degrees. And because A is greater than B, if we replace A with B here, what will happen? If we replace A with B, because B is less than A, therefore B plus C must be less than 180 degrees, right? And according to, remember that we have Euclid's fifth postulate. That means according to Euclid's fifth postulate. So what does it say here in the fifth postulate? If two lines are drawn which intersect a third in such a way that sum of the inner angles on one side is less than two right angles, then the two lines inevitably must intersect each other on that side if extended far enough. This postulate is equivalent to what is known as parallel postulate. So sometimes this postulate is also described in this way. Given any straight line and a point not on it, there exists one and only one straight line which passes through that point and never intersects the first line, no matter how far they are extended. Okay, so basically, if we draw two parallel, if we draw two lines and a third line which is a transversal, so the Euclid's fifth axiom states that if the sum of the inner angles on one side, for example, these two angles are the inner angles on the one side, right? If the sum, let's call this A and B. If A plus B is less than two right angles is 180 degrees, right? If the sum of these two angles is less than 180 degrees, then the two lines inevitably must intersect each other on that side. So that means if I extend these two lines to the right side, they must intersect at some point, right? This is what Euclid's fifth axiom states. Do you understand? If the sum of the inner angles on one side is less than two right angles, then the two lines must intersect on this side. Okay, we can use this axiom to help us prove this. Okay, back to this question. According to Euclid's fifth postulate, because we have B plus C less than 180 degrees, right? And note here, B and C on the same side, and they are the inner angles, right? So according to Euclid's fifth postulate, because we have B plus C less than 180 degrees, therefore M and N must intersect somewhere on the left side, right? So therefore M and N must intersect on the left side. Okay, so note here, we have assumed A is greater than B, right? If we assume A is less than B, then follow the same logic. We can show that these two lines will intersect at the right side, right? So we don't have to write this again. Okay, let's put a note. Note if we assume A is less than B, using the same logic or using the same method, we can show M and N must intersect on the right side. Okay. So no matter A is greater than B or less than B, obviously this contradicts with the fact that M is actually parallel to N, right? Because the question states that M is parallel to N. So this cannot happen. So let's say, obviously, we have a contradiction here, right? Obviously, this contradicts with the fact that M is actually parallel to N. Therefore, that means our assumption is not correct, right? Let's call assumption 1. Therefore, the assumption in 1 is not correct. Okay, the assumption is not correct. That means the opposite should be correct, right? If the assumption A is not equals to B is not correct, therefore the opposite, which is A equals B, should be correct. Therefore, we have proved that A is actually equals to B indirectly, right? Therefore, A equals B. Okay, do not memorize this whole solution. Please try to comprehend the logic behind this proof. Okay, I'll give you the whole notes and you can read the proof after the class. Okay, do you have any questions?
No.
Okay, so far we have learned 5 axioms plus this property theorem, right? And then we can prove anything else using the 5 axioms plus this proved property theorem, right? Okay, let's then try to prove the second property theorem. Okay, the second property theorem states that given two parallel lines M and N, L is a transversal, and the, what is it called here? Remember this? These two angles are called alternate interior angles, right?
Yeah.
Okay, so let's try to prove the property theorem 2. So if we are given two lines that are parallel to each other and L is a transversal, and how we can prove A equals B. Okay, I'll give you a hint. We can use Euclid's 5 axioms. And because we have actually proved property theorem 1, right? Property theorem 1 has been proved. Therefore, we can use Euclid's 5 axioms plus any theorem that has been proved as a base. Therefore, we can also use property theorem 1, right? Okay, I'll give you 1 minute to think about this question.
Okay.
Okay, any ideas? Okay, let me show you how to do this, okay? Okay, let's say proof. Okay, remember that we can use property theorem 1, right? Because we have proved property theorem 1. Property theorem 1 states that parallel lines indicate that corresponding angles are congruent, right? So let's call this angle here is C. We can say because line M is parallel to line N, therefore, according to property theorem 1, we have, okay, apparently C and B are corresponding angles, right? If M is parallel to N, the corresponding angle C and B should be congruent. Therefore, we have C equals B, right? And of course, you don't have to write this sentence here. This is only for helping you understand. And also, because C equals A, right? Because C and A are vertical angles. Vertical angles are equal. Therefore, because we have C equals B and C equals A, therefore we have A equals B, right? Therefore, the proof is complete. Do you understand? And as you can see here, as long as we have proved property theorem 1, the following properties are not very difficult to prove, right?
Yeah.
Okay, let me know if you finish, okay? Then we can move forward.
Okay.
All right, then I'll leave the next one for you to read, okay? For you to do. Okay, let's try to prove the property theorem 3. I'll give you 2 minutes to think about this. Actually, the question is, given that M is parallel to N and L is a transversal, prove that the same side interior angles A and B are supplementary. That is to say, sum of A and B equals 180 degrees, right? Again, so far we have learned that Euclid's 5 axioms and property theorem 1 and 2. You can use either of these or combined to prove the property theorem 3 here.
Uh,
Have you done that?
no. I don't know.
Okay. Because we have already know that if M is parallel to N, then we have property theorem 1 and 2 has been proved, right? Property theorem 1 states that if M is parallel to N, then the corresponding angles are congruent, right?
Yeah.
And also property theorem 2 has also been proved by us. That means if M is parallel to N, we have alternate interior angles congruent. So is it possible to use either of this theorem or combined to prove that A plus B equals 180? Can you see that? You can use either of these theorems here or combined to prove that A plus B equals 180. Okay, so let's have a look at how we can do this, all right? Okay, as I said, you can use either property theorem 1 or property theorem 2 or combined because we have proved such property theorems. Okay, so first of all, because M is parallel to N, for example, we can use property theorem 1, right? If M is parallel to N, let's call this angle here. Let's call this angle here C. Okay, if M is parallel to N, then we have C equals B, right? Can you see why? Because B and C are corresponding angles. Can you see that?
Yeah.
Okay, because they are corresponding angles and M is parallel to N. According to property theorem 1, if M is parallel to N, then corresponding angles should be congruent. Therefore, C equals B. Okay, and because we have also A plus C equals 180, right? Because A plus C is a straight angle, so therefore A plus C equals 180. Okay, according to this expression, of course we can get, if we substitute C with B here, we have A plus B equals 180, right? And the proof is complete here. Okay, can you see the logic? That's how we can prove property theorem 3 using property theorem 1. Can you see that? Hello?
Yeah.
Okay, so let's make a summary. What we have just done. We have proved the property theorem 1, right? Using the Euclid's fifth postulate. Because before property theorem 1, we haven't learned any theorem, right? The only tools we have is Euclid's 5 postulate. And using Euclid's 5th postulate, we have proved property theorem 1 is actually correct. And then based on property theorem 1, we have proved the property theorem 2, right? And also based on property theorem 1, we have also proved that property theorem 3 is also correct. This is what we have just done. Do you understand?
Yeah.
Okay, therefore we can call this property is a theorem. This property is also a theorem. This property is also a theorem because we have successfully proved these three properties can hold at any time in the Euclid's geometry. Okay. All right. And do not forget we have a force. We have a force property, right? I'm not giving you a strict proof for the force property. I'll give you a brief description here. So why this is correct? Because let's say, so this property states that if two lines are parallel, then if we choose the arbitrary point A on line M, and then find the distance between this point and line N, this distance must be a constant, right? So how we can illustrate this is possible. We can choose two arbitrary different points, A and C, and find the distance between these 2 points to line N. Let's call them A, B, and C, D, right? And because M is parallel to N, this angle is also 90 degrees. This angle is also 90 degrees, and this is actually a rectangle, right? And let's consider the area of rectangle ABCD. Apparently, this equals width times with the length, right? So it equals AB times AC, also AC times CD, right? And if we cancel AC to both sides, apparently AB equals CD. And remember that A is an arbitrary point, C is also an arbitrary point. That means if for a arbitrary point on line M, the distance between this point to line N is a constant. Okay, this is how we can illustrate. The force property is also a correct statement. Therefore, we also call it property theorem 4. Okay. All right, so let's use these property theorems to solve some problems. Okay, let's have a look at this exercise question. So we are given two lines M and N, and M and N are parallel. And we are given the measure of one angle in the diagram as shown here. This angle here equals 113 degrees. Your task is to find the values of A, B, C, W, X, Y, and Z. Okay, I'll give you 1 minute to think about this question. Okay. A equals B, what is B and what is C? W, X, Y, and Z. You can write on the screen. Okay. Okay, thank you. That's correct. Okay, let's have a look A is actually supplementary to 113, right? So A is 180 minus 113, which is 67, right? And B is a vertical angle of A, so B equals A, which is also 67 degrees. And C is a vertical angle of 113, so C is just 113 degrees. And W is here. W, because M is parallel to N, so W is the corresponding angle of 113, right? So W is also 113 degrees. And X is the X and B are corresponding angles, right? So X equals B, which is 67 degrees. And Y is here. Y is corresponding to C, right? So Y equals C, because when we have two parallel lines, the corresponding angles are congruent. So Y equals C equals 113 degrees. And C is here. Z and A are corresponding angles, right? So Z equals A, which is 67 degrees. Okay, then let's have a look at the next one. Okay, in this figure, we have line AB parallel to line CD. So this line parallel to this line, right? And line AD parallel to line BC. Okay, this line is parallel to this line. And then this line here parallel to this line. And we're also given the measures of four angles as shown in terms of X and Y. Then find the values of X and Y. Okay, I'll give you 2 minutes to think about this question. And also you can write on the screen.
I don't know how to do this.
Okay, I'll give you, okay, let me show you how to do this. All right, first of all, let's consider line AD and line BC. These two lines are parallel, right? If these two lines are parallel, how about these two angles? These two angles would be corresponding, right? Corresponding angles. Can you see that?
Yeah.
Okay, so this angle is also 3y plus 15. Okay, then let's consider this angle here.
Oh.
This angle is also 3y plus 15, right? Because if you consider this line and this line, these two angles are also corresponding angles, right? Therefore, we have first equation, which means 3y plus 15 plus 3x minus 15 should be 180, right? Can you see that? And because we have two unknown quantities, we need another equation, right? Okay, so note here, this angle is actually vertical to this angle, right? So this angle is x. So as long as we can have this angle As long as we know this angle, then we'll have another equation, right? Can you guess what this angle is?
It's
We need to consider these two lines here. This line, note here, this line is parallel to this line, right? And this is the transversal, right? You see that?
yeah.
And this angle and this angle are corresponding angles, right?
Yeah.
Okay, therefore, the angle here is also y, right? Because corresponding angles are equal. Okay, therefore we have another equation, which means the sum of these three angles equals 180, right? So 3y plus 15 plus x plus y equals 180. Then we have two equations actually. Based on these two equations, we can, okay, first of all, let's simplify them. First equation is simplified to 4y plus x equals 165. Second, x plus y equals 60, right? Therefore, you can use first one minus second one, which gives us 3y equals 105. That means y equals 35, right? Therefore, if y is 35, x is 60 minus 35, which is 25 degrees. Therefore, x is 25 degrees and y is 35 degrees. Okay. Okay, please have a look at this question and let me know if you finish, okay? Do not worry if you do not have time to write them down because I'll give you my notes after the class. You can go over it after the class.
All right.
Okay.
I don't have a question.
All right, then let's see. Okay, the next piece of knowledge is the judgment of parallel lines. Okay. What does this mean? This means under what situation we can determine that if two lines are parallel. Okay. Also, there are 4 theorems related to the judgment of parallel lines. Okay, let's see them one by one. Okay, again, as they have been proved by people correct, therefore we can call them theorems. So let's have a look at these theorems first, and then let's try to prove them one by one. Okay. The Judgment Theorem 1 states that two lines are cut by transversal. If corresponding angles are congruent, then the two lines are parallel. Okay. For example, in this figure shown here, two lines M and N are cut by a transversal line L, and AB are corresponding angles, right? If we have A equals B, then we can decide that M is actually parallel to N. You see, can you see the logic? Previously in the property theorem, we have parallel lines, then we have congruent corresponding angles, right? But in the judgment theorem, direction is reversed, right? It states that if we have congruent corresponding angles, then the two lines are parallel. This is how we can determine if two lines are parallel or not. Any questions?
No.
Okay, similarly, the second judgment theorem states that two lines are cut by transversal. If alternate interior angles are congruent, then the two lines are parallel. Okay, again, I'll draw, here we have a graph and two lines M and N are cut by transversal L. If the alternate interior angles AB are congruent, that means A equals B. If A equals B, then we can decide that M is actually parallel to N. Okay? Any questions?
No.
And probably you can guess the third judgment theorem, right? Third judgment theorem relates to the same side interior angles, which states that if two lines are cut by transversal, if the same side interior angles are supplementary, then the two lines are parallel. For example, in this figure shown here, line M and line N is cut by line L. A and B are same side interior angles, right? If A and B are supplementary, that means if A plus B equals 180, then we have line M parallel to line N. Okay, any questions?
No.
Okay, then the fourth judgment theory states that if every point on line M is located at exactly the same distance from line N, then we can say M is parallel to line N, okay, as shown in this graph. A is arbitrary point on line M, and AB is perpendicular to line N. If AB is a constant, then we have M is parallel to N. Okay, please have a look at this. Any questions?
No.
Okay, actually, this is a reverse statement of property theorem 4, right? And again, as we said, all of these judgment theorems have been proved by people. So let's have a look at how we can prove each of them. Again, usually the first theorem is the most difficult to prove. So let's have a look at the first one. Proof of the Judgment Theorem 1. Actually, the question can be stated as given angle A and B here. If we are given A equals B, proves that line M is parallel to N. So how can we do this? So inspired by the proof of the property theorem, okay, let me give you the proof here, okay? Again, we can't use any of the property theorem, right? Because we don't know if M is parallel to N yet. Property theorem states that only when M is parallel to N, then we have some statements, right? So this time we do not know if M is parallel to N, so basically we can't use any of the theorem, property theorem. Then let's go back to the Euclid's fifth axiom. Again, we can assume M is not parallel to N. If we can find some contradictory, then we can conclude the assumption here is not correct. Then we can prove that M is actually parallel to N indirectly, right? Okay, so let's assume if M is not parallel to N. And okay, if M is not parallel to N, then the two lines must intersect at some point, right? Can you follow me? Can you follow me? If these two lines are not parallel, they must intersect at some point, right?
Yeah.
Okay, so let's say this point is O here. Intersection point O, and this is line M, this is line N, okay? And where is line L? Okay, this is line L. And this is our angle A, right? And this is our angle B. And what can we do? Let's call this point is A, and this point here is B. Okay, then we can from point A make a new line AC, which is parallel to N, right? Because according to the fifth axiom states that, okay, let's see here. Given any straight line and a point not on it, there exists one and only one straight line which passes through that point and never intersect the first line, no matter how far they are extended. That means we can definitely make a line that is parallel to line N, right? Okay, let's call this F, C. And then let's call this point G, this point here, a D, in order to facilitate our discussion. Okay, then we know that actually line AC is and line M must be different lines, right? Because if we pass point A, there can only exist one line that is parallel to the existing line N. So line AC and line M must be different lines, right? And because line AC is parallel to N, then we have angle DAF, which is angle here, right? Angle DAF must equal angle B, right? Because they are corresponding angles. You see that? This line is parallel to this line, and then angle DAF and angle B are congruent. Also, because A equals B, this is a given information, right? Because A equals B, therefore angle GAF must be 0 degrees, right? Which contradicts the statement here, which contradicts the statement 1, right? Because when angle GAF is 0 degrees, that means line AC and M must be the same line. Please follow me. Therefore, yeah, this is a contradiction, right? Therefore, that means our assumption here is not correct. Therefore, assumption M is not parallel to N is not correct. Okay, if such assumption is not correct, that means M is parallel to N, right? Therefore, M must be parallel to N. Because if we assume M is not parallel to N, we can have some contradictory facts. That means assumption is not correct. Therefore, M must be parallel to N. Therefore, we have proved this theory indirectly. Okay, and do not worry if you cannot write this down in time. I'll give you my notes after the class. Okay.
Okay.
All right. Then, if we have proved the first theory, can you prove the second theory now? Okay. The hint is we can use either Euclid's fifth axiom or any theorem that has been proved as a base, right? Apparently, we have proved Judgment Theory 1. So actually, you can based on that theory to prove the Theory 2. Can you do that? I'll give you 1 minute to think about this, okay? Okay, any thoughts? Okay, let's consider this problem this way. Okay, first of all, the given information is A equals B, right? And remember that we can use Judgment Theory 1. So in Judgment Theory 1, it states that if we have congruent corresponding, if we can have congruent corresponding angles, then we can have two parallel lines, right? So this basically the Judgment Theory 1 tells us. So are there any congruent corresponding angles in this graph? Can you find any corresponding angles? For example, let's call this angle here C. Are B and C are corresponding angles?
Yes.
Of course they are, right? Okay, so then we can prove this way. Because A equals B, right? This is a given information. And also A equals C, right? Because they are vertical angles. Remember what vertical angles are? Okay, because A equals B and A equals C, therefore we have A equals C, right? Can you see that? Oh, sorry,
Yeah.
I shouldn't write this. Therefore, C equals B, right? C equals B means we have congruent corresponding angles, right? Then based on Judgment Theory 1, we have these two lines are actually parallel to each other. Can you see the logic here?
Yeah.
So from here, from this step to this step, actually we're using Judgment Theory 1. Understand?
Yeah.
Okay, if you understand, can you try to prove the Judgment Theory 3 is actually correct? Again, the hint is you can use either Euclid's 5 axioms or any theory we have proved correct. Actually, you can based on Judgment Theory 1 to prove this, like what we just did in Judgment Theory 2. Okay, I'll give you 1 minute to think about this.
Okay.
Have you done that?
Yeah.
Okay, I'll give you the solution and you can check if you are correct or not, okay? Okay, let's say proof. Okay, so we are given because A plus B equals 180, right? That means also we know that, let's call this angle here C. Also we know that C plus A is also 180, right? Because C plus A is a straight angle. Straight angle is 180. Okay, based on these two equations, we can conclude that B is actually equals to C, right? Can you see that?
Yeah.
Okay, because B and C are corresponding angles, right? And according to Judgment Theory 1, if corresponding angles are congruent, that means the two lines here are parallel to each other, right? So from this step to this step, actually we're using the Judgment Theory 1 again. Okay, any questions?
No.
All right, then do not forget we have a Judgment Theorem 4, right? Again, I'll not give you a very strict proof here. I'll just illustrate why this theorem is also correct. So this theorem states that if every point on line M is located at exactly the same distance from line N, then M is parallel to N. Okay, we can suppose, again, let's suppose M is not parallel to N, right? Then they must intersect at some point. Then let's say they intersect at some point O, okay? Because if they are not parallel, they must intersect at some point. Let's call this point O. And at point O, we can choose point O and find the distance between O and line N, right? And obviously, at point O, the distance between O and N is 0, right? Can you see that? If we choose a point here and find the distance between O and N, apparently this distance is 0, right? And if we find another point on line M, for example, if we choose another point that is not O on line M, and apparently the distance between this point P and N is not 0, right? And this is actually contradicting with the fact that every point on line M is located at exactly the same distance from line N, right? Again, because we have found a contradictory fact here, therefore our assumption here is not correct. Therefore, M must be parallel to N, right? Do you understand?
Yeah.
Okay, so that means we have proved each of the judgment theorems here. Okay, let's then make a summary. Today we have learned 4 property theorems, right? And then 4 judgment theorems. So let's have a look at them one by one. So property theorem 1 states that if you have 2 lines that are parallel, then you can deduct that the corresponding angles are congruent, right? And the reverse statement is also proved correct, which is called the Judgment Theorem 1. Judgment Theorem 1 states that if you have corresponding angles that are congruent, then we can say the 2 lines are parallel, okay? Please note the direction of the arrows. Okay, then we can combine the property theorem and the judgment theorem to one statement, which reads at 2 lines are parallel if and only if the corresponding angles are congruent. Okay, this symbol here is called equivalent, or if and only if. Okay, which means the first statement here is equivalent to the second statement here. Okay, and follow the same logic because we have proved each of the properties here, right? Because we have proved each of the properties here, then we can combine each pair of theorems to the if and only if statements. So note here, only if you proved each of the statement true, you can combine them, right? Otherwise, if you have a statement like this, its reverse statement is not necessarily true. Do you understand?
Yeah.
For example, I can say Dora is a girl, right? And the reverse statement is every girl is called Dora. Reverse statement is not necessarily true. only if you can prove the reverse statement is true, then you can combine the two statements as if and only if statement. Okay. Okay. I hope you can remember all these theorems that we have learned in today's lesson. Okay. Any questions?
Okay.
Okay, if no questions, this is the end for today's class. And I'll upload my notes to Google Classroom